In this video, we're going to be finding points of intersection of graphs. Now there's a couple ways to do this. You can either solving both equations for y, setting them equal to each other, solving for x, and then plugging that value in to get the y value, or you can solve it as a system by elimination. It's up to you. For this example, we're going to go ahead and solve this as a system using elimination. So we'll be doing this method. So we'll start off by writing our equations. 2x minus 3y equals negative 2, and 4x minus y equals 6. Now it kind of lent itself to it because our x's were already lined up and our y's were kind of already lined up. If they weren't, I could have moved them around so that they were. So we need to decide what would be easier to get rid of. Would it be easier to get rid of the x's, or would it be easier to get rid of the y's? In this case, there's really not a wrong answer, as we just have to multiply by one piece. So I'm going to go ahead and I'm going to multiply both sides by the number negative 3 for my second equation. So what that's going to mean is that my first equation isn't going to change. 2x minus 3y equals negative 2. However, when I do the distribution here, my second equation will change, and it will become a negative 12x plus 3y equals negative 18. Then I will combine those together, and that will give a negative 10x, the y's will go away, equals a negative 20, and then I'll solve from here. So I will divide both sides by negative 10 and get x equals 2. Then from there, I need to decide which equation to plug my x value in for. I could plug it in for this first one or the second one. It doesn't matter. I'm going to go ahead and I'm going to plug it in for the first one. That sounds good. So I'm going to leave an opening for my x variable, and then 3y equals negative 2. I'll plug in my 2, and I'll solve. So now I have 4 minus 3y equals negative 2. I'll subtract 4 from both sides and get negative 3y equals negative 6. Divide both sides by negative 3, and that will give me y equals 2. So here I see that my intersection point will be at 2, 2. And that is how you find the intersection point algebraically. Well, what if I wanted to find it graphically? So we're going to use a graphing utility for this next part to approximate the points of intersection of these two equations. Y equals x squared minus 3x minus 4, and y equals x to the third plus 3x squared minus 2x minus 1. It's important to make sure when you're using your graphing utility that the y is always by itself so that you can plug it into the equation. The first thing that we're going to do after we've gotten the y's by themselves is to plug each equation into the y equals of our calculator. So here we can plug in our x squared minus 3x minus 4, and then in the y2 spot, we're going to plug in our next part of our equation. Let's see if I can move this so I can see it. So x to the third plus, oops, that's up in the wrong spot, arrow out. Okay, so then plus 3x squared minus 2x minus 1. And then once I've done that, I'm going to graph the equations. So that's going to be my second step. So once we have those plugged in, then we're going to graph the equations. So here we have them both plugged in, and we're going to hit graph, and now we see our two lines. So we have our first equation, which is blue, and our second equation, which is red, and we want to know where approximately do they intersect. And to do that, we're going to use our second trace menu, which is our calculate menu, and the intersection option. So here we'll go to second trace, or a calculate menu, arrow down to intersect, and it's going to ask us two questions. What's the first curve? What's the second curve? And then it'll ask us if we're ready to approximate. So our first curve is our blue line. So are we on the blue line? Yep. Now, because these only intersect in one place, it's not that big of a deal. But usually you want to get kind of close to that point of intersection to make sure that you're not going to get the intersection in another spot. But here they only intersect the one time. So we're going to hit enter. And then it's going to say, okay, what about the second curve or your second function? Notice that it's written in red, so it's like, is this the function you want it to be? And so here we can see that we are really close to that intersection point, so we're going to hit enter. And it says, are you ready to guess? Because remember, our graphing utilities just give us an approximation. So we're going to go ahead and say yes, because we've selected both of the lines that we want, and we're next to the intersection point in both spots. So we'll hit enter. And it tells us the intersection is approximately at negative 2.174, comma, 7.252. So if we round those to 2 decimal spots, we get negative 2.17 for our x value, and for the y value, we'll get 7.25. And so here we have our intersection point. Now it might be a good idea to give a little sketch of what those look like. So we'll pull up our graph, and we'll sketch our blue line, which is going to look something like this. And then we'll graph our second equation, which is going to look something like this. And we'll just double check and make sure. Oh, it looks like I needed to have a little more down swoop there. So we'll go ahead and we'll just fix that red one. And so we'll take one final look. And that looks a lot better. So we have our sketch, we have our intersection points, and so that's how you do it to get that approximation of those intersection points using your calculator. So we've just gone over how to find the intersection points of two functions algebraically and graphically.